Hello, algebra students! This lesson video is going to be about graphs of functions in standard and factored forms. The last 4 lessons of this unit are all about graphs of quadratics, and so this is the first of those 4 lessons. There is a warm-up question on the screen to help get you ready for this lesson. Pause the video here and try answering those questions yourself, and then come back to the video to see how you did. To go over these warm-up questions, I am going to move down here where it's a little bigger. We are given the graph of this equation here, and these 3 questions are about how you can connect the equation and the graph. So starting with the 8, in this equation, we see this constant, this number 8 here, and where do we get to see that on the graph? We see it right here. That constant, that plus 8, ends up being our y-intercept. It is where our graphed line, that blue line, crosses our y-axis. Next, I see the number -2 in our equation. That is the slope. It's the number that's with x. That -2, where do we see that on the graph? Well, remember, -2 is your slope, and we think of slope with the formula rise over run. So that -2 is a little harder to find than the y-intercept, but it's still there. This line is going down 2 and over 1. Down 2 boxes and over 1. Down 2 boxes and over 1 until we get to this point here, which is what number 3 asks about, is what is the x-intercept of the graph? The x-intercept of the graph is right here at the number 4. And so our x-intercept, I'm going to write it as a point. It's at 4, 0. And how does that relate to this equation? Well, we know x-intercepts are where, even if I didn't see this number, I always know y-intercepts are where the point has a 0 for the y-coordinate. And so if you think about this equation, if you make y 0 in that equation, and then you solve this equation here, you end up getting where that x-coordinate is. You get the x-coordinate, the x-intercept is, you get our x-intercept is at the number 4. That would be true for any point on your x-axis. Is any point on the x-axis has 0 for the y-coordinate, and if you put 0 in for y into the equation, it'll find out where that x-intercept is. Now, these warm-up questions weren't about quadratics. They were about linear equations, but what we're going to be doing today is similar. We're going to be finding ways to connect standard form and factored form to the graph of those quadratic equations. So here is the goal for this lesson. First, I can explain the meaning of the intercepts on a graph of a quadratic function in terms of the situation it represents. And then second, I know how the numbers in factored form of a quadratic expression relate to the intercepts of its graph. Notice we are using those words factored form. We had learned in the previous lesson that factored form is when your quadratic is written as a multiplication problem. So for example, maybe x minus 3 and 4 plus x. That is factored form as opposed to standard form. Standard form is when your equation is written as ax squared plus bx plus c. Standard form always has that quadratic term. There might be a bx, there might be a c, but standard form is what we were getting in that last lesson when we multiplied all of this out and simplified it. Standard form looks something like this. So for example, maybe 4x squared minus 8 would be standard form. So we're looking at how that form of the quadratic relates to the graph and its intercepts. To get us started, this is going to be the first part of the lesson, is we are going to be looking at some pairs of expressions in standard form and factored form. Each pair of expressions defines the same quadratic expression. We've learned that it's the same quadratic, it's just written 2 different ways in 2 different forms, but the graph for both of them would be the same. Our goal is going to be to identify the x-intercepts and the y-intercept of each graph. So for example, here's our first one. We've got these 2 expressions of quadratics. Now they are equivalent. They both represent the same quadratic function, which is this graph over here. Our job is looking at the graph first. I want you to identify the x-intercepts and the y-intercept. There's going to be a second part to this question, but start by finding where these points are. For this function over here, our x-intercepts, remember you can always find them on the x-axis. It's where that blue line and the x-axis cross, and so that's going to be here and here at -1 and -3. So our x-intercepts are going to be at -1, 0 and -3, 0. Our y-intercept is right here, same idea, where our graphed line, that blue parabola, crosses our y-axis, and that is at the number 3. So our y-intercept is at 0 on x and 3 on y at the point 0, 3. Now, our goal of this problem set is by the end of all of these different examples, I'm going to be giving you something like this. I'm going to be asking where the x-intercept and the y-intercept is of something like this, but I'm not going to give you the graph. So we'll do the first couple examples together, and as you look at our answers, our x-intercept and y-intercept, see if you can figure out how we could get this information just from these here, not from a graph. Because by the end of this, like I said, I'm going to give you 2 of these expressions and ask you to identify the x-intercepts and the y-intercept without giving you the graph to find the answer. And so take a moment, pause the video if you need to, and see if you could figure out how we could get the -1 and -3 x-intercepts from these expressions and where we could find that y-intercept at 3 from these expressions. We're going to move down and do one more. So here, same question. What are the x-intercepts and the y-intercept of this parabola over here that's represented by these 2 quadratics? Pause the video here, identify the x-intercepts and y-intercept, and then come back and see how you did. For this one, our x-intercepts are here and here, so that's at the number 1 and 4. And so we have an x-intercept at 1, 0 and at 4, 0. For our y-intercept, that is right here on our y-axis, so that's going to be at 0, 4. Again, we want to see, could we figure out what about these 2 expressions would help us identify the x-intercept and the y-intercept if we did not have a graph? Start to see if you can find some connections between these numbers and these expressions. At this point in class, there's usually one that people start to notice. So looking at our y-intercept, for this function here, our y-intercept was 4. And for this other one we did, our y-intercept was 3. And if you think about that warm-up we had done, our y-intercept was the number 8. All 3 of those, even though that first one is not a quadratic, all 3 of those have something in common. Sometimes at this point in class, students start to notice, if we look at this first expression, this expression in standard form, I'm noticing the constant, the +4 and the +3, that matches up with our y-intercept. We've got a 3 there, the +4, we've got a y-intercept of 4. And so they start to think maybe the standard form, it's that constant, that number all by itself that represents the y-intercept. The x-intercepts at this point usually are a little harder for students. We've got a 1 and a 4 here. Up here, we've got a -1 and a -3. Maybe you have an idea. We'll do one more and then we'll talk about those x-intercepts. For this one here, one more time, pause the video, find your x-intercepts and your y-intercept, and then come back and see how you did. So this time our x-intercepts are right here at -3 and at +3. Did I say y-intercepts? Our x-intercepts are at -3 and +3. So we have an x-intercept at -3, 0 and at +3, 0. And then our y-intercept is all the way down here at -9. So that would be 0 on x and then -9 on y. So at this point, we're feeling pretty confident that -9, our y-intercept, is again matching up with this constant here. And that is going to be true for the rest of these. If you made that observation early on, congrats. Anytime you want to know the y-intercept, we are looking at this first one here. We are looking at standard form. And that constant, that number all by itself in your standard form, that is your y-intercept. The other part to this that maybe sometimes students in class start to notice is the x-intercepts and where they're coming from. It's a little harder, like I said. You may have noticed so far that the numbers, not the signs, but the numbers seem to be consistent with what we're seeing in factored form. In factored form, we've got x plus 3 and x plus 1, and our intercepts were -1 and -3. For the next one, I see a -1 and a -4 in factored form, and I've got a 1 and a 4 as my x-intercepts. Here, I'm seeing a -3 and a 3 for our factored form, and my x-intercepts are at -3 and +3. So we're noticing there's a connection between those numbers. Sometimes students guess it's the numbers you see in factored form, but just the opposite sign. But we're seeing x-intercepts are related to factored form. It's not exactly the numbers, but just the opposite sign, though. And to help us talk about why, some of these later ones are going to help us out. So let's do one more here, and then we'll talk about how we get the x-intercepts. So for this one, go ahead, pause the video, identify your x-intercepts and your y-intercept, and come back. So starting actually this time with the y-intercept, we had said above that you can look at standard form and find the constant, and that is the same as your y-intercept. Notice here, we don't have a constant. There's no plus or minus a number, and if you don't see a number, what number represents no number? That's the number 0. If that constant is missing, your constant is 0. And sure enough, if we look at our y-axis, that y-intercept is there at 0. Our y-intercept is at 0, 0. Now for the x-intercepts. When we look at our graph, our x-intercepts are also at 0, 0, as well as this point here at the number 5. So we have x-intercepts at 0, 0, and at 5, 0. The way we connect this to our factored form is actually similar to what we did all the way back up here with our linear equation. We had said for those x-intercepts, you can connect them to the equation because it was where y equals 0. Remember how we switched out the y for a 0 and we solved this equation? The same thing is going to be true down here. If we wanted to find our x-intercepts with no graph, we are going to take our factored form and make each part equal to 0. And when I say each part, I mean each thing you're multiplying. So for this left part, I would make x equals 0. Well, that's already solved. That's very easy. And then for this other part, I would make x minus 5 equals 0. And to solve that, you add 5 on both sides, and we get x equals 5. This is why a lot of times we're seeing it's the same number, just different signs. But knowing that you need to set it equal to 0 is going to be important for more complicated factored forms. Like we've seen factored forms where it's not as simple as these. You might have 2x plus 7 times 4x minus 10. And it's not as simple as just switching a sign, right? We need to know this idea of making it equal 0. And so that is the final piece here. There are 2 types of expressions, one in standard form and one in factored form, and each form tells me something different. We've got that we want to look at standard form to find our y-intercept, and we want to look at factored form to find our x-intercept. So keeping that in mind, here's our first one where I'm asking you to find these, but I did not give you the graph. Please try this. Please, please, please pause the video and see if you can come up with a prediction of where the x-intercepts and the y-intercept are going to be. After you come up with your answer and you come back to the video, I'm going to put the graph on the screen so that way you can check and see if you predicted them correctly or not. Go ahead, try now. All right, so here's the test. Remember, to find the x-intercepts, you should have been looking at factored form. And to find your y-intercept, you should have been looking at standard form. So I'm going to scroll down, show the graph, and show what the correct answers are, and then we can talk about how you would figure them out if you had trouble doing so. So down here, from this graph, we see that the x-intercepts are at 0, 0, and 5, 0, and the y-intercept is also at that 0, 0. So let's talk about how you figure that out. For your y-intercept, we'll start there. We said the y-intercept, you're looking at standard form, and it's the constant. Just like the one we did above, this expression here doesn't have a constant, and so the constant would be 0. And so we get from that, the y-intercept is at 0. It is at the point 0, 0. For your x-intercepts, we said to find the x-intercepts, you want to set each part that you're multiplying, each factor that you're multiplying equal to 0. So that means here I'm multiplying x by 5 minus x. So I'm setting x equal to 0, and I'm setting 5 minus x equal to 0. I think this problem's really important because if you got stuck in that trap of thinking it's just the opposite sign, this 5 minus x shows us why that's not true. Here I see the number 5, so maybe I'm thinking it should be negative 5. But if I solve this equation, I'm going to move x to the other side, and I see that x is the number 5 because 5 minus 5 is what would give me that 0. This first one's already solved, and so we have an x-intercept at 0. That would be the point 0, 0. And we have an x-intercept at 5. That's the point 5, 0. And so that's where those answers came from. We've got another one like this to try. So again, here is standard form and factored form. Pause the video. Please, please pause it. Practice is important. And see if you can predict the x-intercepts and the y-intercept. So just like before, I'm going to show the answer and then we can talk about where it came from. Here are the answers. This time there is only one x-intercept and it is at -2. And then there is one y-intercept at the number 4. Congrats if you correctly predicted that. If you did not, let's talk about how you get those answers. For our x-intercept, we said we're using factored form, and for our y-intercept, we're using standard form. Y-intercept, I'm looking at standard form for the constant. The constant is 4, so that is how we have a y-intercept at 4. For our x-intercepts, we said we set each factor, each part you're multiplying, equal to 0. When we go to do that, you've got an x plus 2 equal to 0, but then notice you also have an x plus 2 equal to 0. It's the same thing. You don't need to solve both. We just need to solve x plus 2 equals 0, and to do that, you subtract 2, and you get x equals -2. If you solve this one down here, you get the same answer, x equals -2. So this time there is only one x-intercept, and it is at -2, 0, like we see down here. So to summarize, this would be a great thing to include in your notes. We've got factored form is more helpful for finding x-intercepts, and standard form is more helpful for finding y-intercepts. In order to find the x-intercepts, you are setting each factor, each part, equal to 0 and solving. And I've got an example here. So for example, if this was our factored form, we need to make x minus 2 equal to 0, and we need to make 3 minus x equal to 0. And when you solve those two equations, you get the numbers 2 and 3 for your x-intercepts. For your y-intercept, I personally just find that one a little easier. You are just looking at standard form and identifying the constant. And we said the constant is the number that doesn't have any variables. So looking at standard form here, here's my constant, and so my y-intercept would be at -7. This is the first lesson, like we said, of 4 lessons on graphs of quadratics. And this is going to be a really important step for us to know when we go to actually create these graphs ourselves. The second part of this lesson is using all of this information we just learned in real life situations. If you think about those learning objectives, one of them was being able to connect the forms to the graph. But then the second part is being able to identify these intercepts because they communicate important information. If you think all the way back to our first unit we did on functions, we said some of the places you look at a graph for those really important points are your intercepts. And so understanding what they mean is going to be the focus of the second part. For our story, we are going back to an earlier lesson where we had seen this equation here. This equation models the height of an object thrown upwards from a height of 10 feet with a vertical velocity of 78 feet per second. That's something we had learned in a previous lesson, that your constant tells you the height you're throwing the object, and then that 78 feet per second, that represents our velocity. Velocity means the same thing as speed. Looking at our equation here, the first question is the expression 10 plus 78t minus 16t squared, is that in standard form? And explain how you know. Go ahead, pause the video to try that now, and then come back to see how you did. So the answer to this first question is yes, it is in standard form. I know it's in standard form. There's a couple ways you can explain because it is an ax squared plus bx plus c form. It is in a different order, but it's still in that form, in that standard form. You could also say because it has a t squared in it. We had talked about standard form always has that t squared. There's a second part though you want to mention. It's got that t squared and is simplified. There's no other math I could do there to simplify it. I can't combine like terms. I can't do any multiplication. This is as simple as it gets. So a couple different ways you could explain recognizing it's in standard form. The second part is using this new information we learned today. So we've got Jada. Oh, I'm sorry. This is not the new information yet. This is looking at this equation. She says it also defines the same function. It's just written in factored form. Think about how could we show that she is correct, that these both represent the height of this object thrown. Again, pause the video, try this problem now, and then come back to see how you did. So this actually goes back to the last lesson where we talked about how you can change expressions like this into standard form. We had learned two different strategies for doing this. We said you can use a diagram to multiply all this out, or you can use distributive property. Because of my space here, I'm going to go with distributive property. It says we want to start by distributing the negative 16t to both of these terms. And then we want to distribute the negative 2, make sure you get that sign, to both of these terms. And so when we do that, negative 16t times t gives us negative 16t squared. Negative 16t times negative 5, we can do that in parts. Negative times negative gives us positive. And then 16t times 5 gives us 80t. Then we distribute the negative 2. Negative 2 times t is negative 2t. And negative 2 times negative 5, negative times negative is positive, and 2 times 5 is 10. This is not our final answer, though, because we still have to do some simplifying. And when you simplify and combine 80t minus 2t, guess what you get? You get this equation right here. It's got the 10. 80 minus 2 gives us that 78t, and then we've got that negative 16t squared. So this would be one way you can show that Jade is correct, that this also represents the same equation. Remember, you could have also used the diagram as well. Now the part I'm excited about. This is using what we've learned today about those intercepts. So we've got, here is a graph that represents both of those equations. Again, it's the same equation, just written in a different form. The two questions I'm asking you to do is identify or estimate the vertical and horizontal intercepts. Here we're switching to the words vertical and horizontal intercepts because our graph isn't x and y, like we've got a t. Remember, vertical is up and down, horizontal is sideways. And then the second part is, what do each of these points mean in this situation? Pause the video now and try to identify these intercepts as well as identify what they would mean for the story. Starting with our vertical intercept, or the y-intercept, I can find that on our graph right here, and it looks like it's at the number 10. I can confirm that by using one of these equations. We learned the y-intercept you can connect to standard form, and sure enough, there is the number 10. So for our vertical intercept, it is at 0 on x and 10 on y. I'm going to go ahead and do the second part of this. What does this mean in this situation? We were actually told in the story. If you come back up to that story It says this equation models the height of an object thrown upwards from a height of 10 feet with a vertical velocity of 78 feet per second. That 10 is right here. It is not just the height of the object, because the height is changing, right? When you throw an object, the height changes over time, but it is the starting height. It is the height at time 0. So we could say the starting height of the object. You could also say the height the object was thrown from. I really like that too. This is one of our intercepts, our vertical intercept. Our other intercept, looking at the graph, is right here at the number 5. If we did not have this graph, how could you find that? Using factored form. We've got 2 factors here. If you set t minus 5 equal to 0 and solve it, it gives you t equals 5. Now I see there's 2 different factors here for us to set equal to 0, but my graph is only showing 1. What do you think happens if we find the other one from this factor here? Well, if we've got negative 16t minus 2, if you set that equal to 0 and solve, you get negative 16t equals 2 when you add 2 on both sides. And then when you divide the negative 16, you get t equals negative 2/16 or negative 1/8. Why do I not see this one on the graph? Well, that's because it's on the left side of your vertical axis. It's on the left side of that y-axis. If this line kept going back here, there would be another one right here. So why is that not included on this graph? Well, it has to do with the second part of what does this mean? We see the x-intercept or the horizontal intercept at 5, and what does that mean? Well, t equals 5 means we're talking about 5 seconds. And what's so special at 5 seconds? Well, at 5 seconds, that point is at 5, 0. It means at 5 seconds, 0 is the height. It means at 5 seconds, that is when the object hits the ground. This other one doesn't make sense because you can't have a time of negative 1/8 of a second. And so that's why we're only showing this positive horizontal intercept. So we've got our horizontal intercept is at, I'm going to write this as a point, at 5, 0, and it means the object hits the ground after 5 seconds. You can say the height of the object is 0, but that sounds kind of weird to me. Like if you leave school, you leave math class, and there's something on the ground, you're not going to say, yes, it is at a height of 0. You're just going to say it's on the ground. So taking that a step further and thinking about what a height of 0 means. This right here is an example of the second part of what we are doing. We are going to spend more time practicing this. The very last lesson actually is just only looking at like real life situations like this, but this is giving us the idea of why being able to find these intercepts are important. Each of them tells you something special in the story, like the starting height and then the final part, right? When the object ends its journey and hits the ground. There is one question left for you on the screen. This will be a great way for you to check in and see how you're doing at being able to predict x-intercepts and y-intercepts from graphs. Go ahead, pause the video here one final time and try this practice problem. Well, first, we are given this right here, and this I know is in factored form. I know it's in factored form because I see those parentheses, I see it's written as a multiplication problem, and we have said factored form helps you with the x-intercepts. So to find our x-intercepts, I am using factored form to help. We said in order to find those x-intercepts, you are setting each part equal to 0. And when we do that, here you get x equals 9, and here you get x equals 1. There are 2 x-intercepts, and they are at the points 9, 0 and at 1, 0. Now to find the y-intercept, we said we want to use standard form. But our problem here is I did not give you standard form. Does that mean there is no hope? No, of course not. We learned in the last lesson how to change this to standard form. So we're going to have to do that. I'm going to take my x minus 9. Actually, let me do this one with the diagram since we did the other one with distributing. So if you like the diagram method, we've got on one side, it doesn't matter if it's the top or the left side, but on one side you need your x minus 9. On the other side you need your x minus 1. And then we do those 4 multiplication problems. X times x is x squared. X times the negative 1 is negative 1x, or just negative x. Negative 9 times x is negative 9x. And then negative 9 times negative 1. Negative times negative is positive, and 9 times 1 is 9. So we get for our y-intercept, I'm using x squared minus 9x minus x plus 9 to help me out. I do want to go ahead and simplify this just to make it properly in standard form, although we already know looking at this what the y-intercept is. This right here, though, would be standard form. And when you look at standard form, we said the y-intercept is always our constant. And so here, your y-intercept would be at the point 0 on x and then 9 on y, y-intercept at 9. These are the x-intercepts and the y-intercept of this graph right here, and we didn't even have a graph to figure that out. Isn't that cool? I think so, but I'm a math teacher, but hopefully you do too. This is the end of this lesson here. We, like I said, are going to continue to talk about graphs in tomorrow's lesson and use all of this fun stuff you learned today. Thanks so much for watching, and I'll see you in the next one.